On Tuesday, December 28, 2010, members of the Arizona State Legislature were briefed on a new concept for border protection. This video is a summary of that briefing. Attending the briefing were State Senators Russell Pierce, Gail Griffin, Al Melvin, and Andy Biggs, and State Representative John Kavanaugh. Briefers were Glenn Spencer of American Border Patrol, Mike King of Border Technology, and Craig Walters of Basin Geophysical. The briefing was held at 8 a.m. in Senate Caucus Room 1 at the Arizona Capitol. Phoenix is the capital of Arizona. 185 miles away, on a ranch on the Mexican border, a seismic detection system known as the sonic barrier had been installed. The briefing involved a live demonstration of the system. This was done using an internet-controlled thermal camera installed on a 50-foot mast at the ranch. The camera showed people walking from the border to the sonic barrier. As they did, another computer screen displayed on the wall of the meeting room showed how sensors buried in the ground reacted as they approached.
So what we are going to be showing you today is a way to solve that problem. It's essentially a border counting system. It's more than just a detection system. It's a way to count everybody that's on the border. What we're going to do is we've got some people down on the border. Mike, you want to get them started? And we're going to have them walk.
All right, well, let's move out.
From the border down here toward this line of sensors.
Yeah, go ahead. Pay attention to from left to right, 4, 5, 6, 1, 2, and 3. Those are the traces we have out right now. We have the ability to run the entire border, with seamless coverage. So what we're going to be looking for is one of these lines. I don't know which one they're going to come on. I told them to surprise us. So between 4, 5, and 6, 1, 2, and 3, we're going to watch those lines. This covers approximately 1/4 of a mile of area. And if you notice on 4 is really starting to come alive. So what I'm going to do here is I'm going to come over to the camera here. We're going to check on sector 4 here and see what we got. What we're looking for is a disturbance on one of those lines, and it'll become more obvious as they get closer. So far what we've noticed is the detection range is roughly around 200 yards.
The core element is the geophone itself. I don't know if you saw those pictures there. It's the one with the red casing and the spike kind of right there in the middle. I used to take one of those on my kids' career day when I go to their school, and I'd bring one of those with a little display set up, and I'd hook it up to a little meter. And I'd go out there and I'd have $5 sitting out on the table. Kids come over there and look at it and say, all right, you hold that geophone still, keep that needle from moving, you get the $5. Well, you know, it might as well have been $1,000, because as long as that kid's heart's beating, it's going to pick up those vibrations. It's going to pick up the vibrations of the floor walking around. Because of him, you're extremely sensitive.
You can see the disturbances coming on 6. Okay. Going over to 6, and we're going to pan to the left and see who's coming.
Is this measuring noise? Is that what...
This is measuring seismic.
Oh,
it's measuring like an earthquake. And they're creating a seismic anomaly. Now we're good. There they are. And there's our border travelers. Now, if you notice how far I pan to the left, they're probably right there. They're over 200 yards from the sensor line right now. We've already detected them, and you can see that as they get closer, it's getting bigger and bigger. Now, that stuff right there the human footstep is a very unique signature. The human footstep is a very unique signature, seismic. And so, with fairly simple software,
pan right,
it will determine whether it's human or animal. This will also detect aircraft, ultralights. It'll detect tunnel digging, and all this stuff at fairly substantial range. Aircraft we can detect from like almost a mile.
Okay, keep going, follow them up.
And
there's a sensor going off right now.
Yeah, 5 and 6 are getting crazy. So this provides an absolutely seamless if it was laid out from San Diego to Brownsville, Texas.
Absolutely
Seamless coverage. You can't tiptoe across this. It is that sensitive. This isn't even, I have this thing turned down so you don't actually, so it's easier to see, but
Come to the pan right.
I'll turn it so you can actually see what we can really see.
Mike, pan
Hold
right.
on 1 second. As I zoom in,
they're just
this
about to hit
is
the
more
line.
realistic is what we're going to see. And there you can see how big actually the signal is that they're creating.
Is this one line of sensors parallel to?
No, they're right on
Yes.
the sensor right now.
Yes, they're
They're
Each
standing
right
of those
there.
lines is in actuality, this would be one super long
Definitely.
line, but you broke them into segments?
Yes.
Horizontal?
I can show you that we actually have been working with this for many, many years. It wasn't until the concept was married between the entire system that Craig operates and the signal processing that Border Technology does, that we realized, we sat down and we said, wait a minute, this entire system can be run on the entire border. The technology is there now. The systems are designed, they're hardened, they've been used for decades. This is the more recent technology, and it can be stretched. It is the lowest cost system that we have seen.
Just to kind of give you a little background, I've been looking at these wiggle traces when I'm collecting seismic data for oil and gas exploration for almost 20 years now. And a lot of times I'm just looking at the ambient noise going across, and I could tell just by looking, just visually looking at my screen, whether people were coming across, a pickup truck was coming by, a plane was flying over. I mean, I'm in an enclosed room where I'm doing this recording in a remote location out in the field. And I could actually tell what's going on outside that room by looking at the little wiggles on the line. It's just a trained eye. Now, what Mike's is proposing here is taking this little wiggle trace and turning it into a digital signal, applying an algorithm to it, and actually extrapolating, boom, this is 5 people walking across. This is a mule that's kind of wandering by himself. This is a Border Patrol truck coming down the road. And he'd be able to essentially just automate all this. So all you basically have to do is just turn it on.
Panel battery, the seismograph unit itself, the electronics. We have cables strung out in either direction on there, and then you can see there is these right here. These would be 220-foot strings of geophones in the ground. And then these all feed back to here and then go out on a bus cable, and then okay, so this was the one we just previously looked at. Each one of these is one of these. And these all feed in for 5 miles per segment. Back to here, back to computer, back to part of our internet backbone. It takes us to this right here. Each one of those is one of these here. This is the 5 miles. Comes in here. These all feed back to a center internet site. This has all been worked out already. It's already all commercial off the shelf. None of this is in development. This already exists. Comes back here to a very simple, very inexpensive. This is a very low bandwidth system. This isn't like we're trying to feed video over it. We're feeding very little data over this to a simple, such as a home-based internet connection, satellite internet connection you would have at home if you lived in a rural area. Very inexpensive. And out over the internet, feeding to a central location, to a single IP address that's taking in all this data, counting, alerting, or whatever that the state wants to do.
Depending on ballpark where it is, determines whether it's something we can do or something we just simply say to the feds, you do, which they never do.
Which they never do. Well, it's less than $2 million.
You're right. We need to have an area with high traffic, and either way we win. Because if we call the Border Patrol and they have massive apprehensions, then the headline is, this system works. if we call the Border Patrol and they don't come, and we have mass crossings, we can say, look what they're letting happen. So I mean, either way, you're going to push them towards securing the border. Okay, would I be correct in assuming that because this is so minimally invasive in terms of its physical presence, that there wouldn't be issues of environmental impact statements and, you know, disrupting the migration of the, you know, Arizona horned toad if there is?
They've got it buried right there. You've got a little trencher. And what the thing is, if you come upon a cactus, you just go around it.
Yeah. Well, I mean, it seems like this is no more invasive than putting fence posts in for a cattle fence. What is the manufacturing capabilities such that if a decision were made, this could be become operational within a matter of months?
Are we talking about the whole border?
No, test
one, absolutely.
Craig?
Well, what would be a timeline, a reasonable timeline?
I spoke with them, and something like that would be real straightforward.
Yeah,
Almost immediately.
10 miles, you could have it in a couple of weeks.
We'll have the equipment. Yeah.
Well, you're going to get the equipment. It depends on how many people with little trenches.
Well, believe me, we don't act that fast.
Right. And we have a procurement process. We have a procurement process. I mean, government doesn't move quickly.
So we
But
do
as far as
months than weeks.
a lot of problems with the Border Patrol and hundreds and hundreds of millions of dollars being thrown at that problem without any way of knowing if it's working. This is how you protect it.
How about maintenance? In terms of, is there preventative maintenance that has to be done on a regular basis? And what about the breakdown of the units, replacement? What's your experience?
My experience on the maintenance is typically the issue is exposure to weather or elements or, you know, animals. But if you bury the lines like we're talking about here, you don't have to worry about the majority of that.
Okay, so like the sense, it's not like changing light bulb, the sensors where you got to send somebody every week to change.
No, sensors, they'll last indefinitely. They're extremely ruggedized. Like Glenn was saying, they've been using them in the oil field since the 50s. The geophone essentially hasn't changed since then. Extremely sensitive, extremely reliable, and if you put it in place, it's going to do its job.
Ballpark about $2 million for 10 miles.
Oh no, no more than 2 million.
For 10 miles.
Less than 2 million.
Okay.
For this initial test
So we could go 5, we could go 15. We're
You
not
can go
that locked
5.
in. Or we go 15. I mean, we're not that locked
Those
in.
are all decisions that we make.
Right, but I'm saying in terms of, but when you give us a list of sites, your suggestions, right? Don't just lock yourself into 10 miles.
Right.
You know, I mean, we can go up a little, down a little. So
Yeah, they can be built efficiently in segments of 5 miles. And you piece them together. Each is independent.
Yeah, Al, do you have a card to give? I gave one. I think you already got a
okay,
card.
so it'll be the 3 of us
Good.
for that January.
Good choice. Excellent.
Just tell our, just keep hold my secretary. Just tell her, you know, they'll coordinate the day when we're all available. And then you'll have some possible locations, something more firm in terms of cost.
Yeah, we'll have it more firm in terms of cost, and then when we come up, we can actually run this demonstration with even finer data.
Did you guys want cameras in this, or do you just want the seismic line?
I don't know. Why don't you give us a cost on both? And you should probably, in anticipation that this gets kind of favorably reviewed and we go before appropriations, you might want to try to put together a presentation, but maybe like no more than 15 minutes. Because it's approach we can't do like 2 hours on an hour. So if you could get things distilled down into like 15 minutes, PowerPoint slides are usually nice. You don't have to necessarily have the live demo. I mean, you could if you wanted to, but you know, just PowerPoint slides, you know, often works.
Okay.